Today, I'm going to show how you can call a C library compiled to WebAssembly using Python. We're going to use a library called PythonMonkey to accomplish this. First, we're going to write a sample C library. Then we're going to compile it to WebAssembly using emscripten. And then we'll load that WebAssembly library into Python and call it using PythonMonkey. PythonMonkey is a Python library that lets you execute JavaScript and WebAssembly from Python. It uses a JavaScript engine built by Mozilla for Firefox called SpiderMonkey to evaluate JavaScript and WebAssembly code. And it interoperates very smoothly with Python. You can pass objects back and forth, functions, and so on. And that's why we're going to use it for today's example. The first thing we have to do before we get started is install emscripten. We're just going to go to the emscripten website and follow the instructions here. I'll post this in the description of the video, and it'll also be linked in the article. I'm just going to run these commands. Great, now that that's done, let's run the next command. Cool. And then let's source this. Great. So now that that's installed, we have to make sure that we have Python 3.8 or higher installed on the system. I'm just going to check my Python version. Great. I've got Python 3.10 installed. That means that I'm good to go. If you have a version below 3.8, you might have to consider using a virtual environment or some other way to run Python code 3.8 or higher. Now we'll have to install PythonMonkey. This is the Python library I mentioned before that's used for executing JavaScript and WebAssembly code. So to install that, just type Python 3 -m pip install PythonMonkey. I've already got it installed, so it's done for me, but there might be a little bit more time for you. Great, now that we've got that set up, let's get out of that directory and let's make our C project. I'm going to call this folder, I don't know, C library testing, I don't know. And I'm going to make a C file. We're going to call it lib.c. And I'm going to put in a function that takes two numbers and adds them together. So int add, int a, int b, and then we'll return a plus b. But in order to get this working in WebAssembly with emscripten, we're going to have to do a couple more things. Number one, we'll add emscripten keep alive above the function. And we also, at the top of our file, we have to include emscripten.h, the emscripten header files. Cool. Now that we've got that done, let's compile it using emscripten. The command will be amcc lib.c -s wasm equals 1 -s space side underscore module equals 1 -o, and then, I don't know, my lib.wasm. Maybe I could have come up with a better name. Great, so that compiled fine. If we ls, we'll see that my lib.wasm has been compiled from lib.c. Let's create a Python program that tries to execute this now. I'm going to call it main.py. And the first thing we want to do is import PythonMonkey so that we can use JavaScript and WebAssembly. I'm going to paste in the rest of the code and then I'll walk through it. Awesome. I'm just going to walk through the code now and kind of explain what's going on. So this is the line where we import PythonMonkey, and I'm just going to label it PM just for simplicity so that we don't have to type PythonMonkey everywhere. We can just do PM. This line here is, you can kind of think of it like an import statement. Basically what it's doing is it's ripping the WebAssembly module from JavaScript and putting it into Python, and we're assigning it into this variable that happens to be called WebAssembly as well. And then these lines are reading the WASM file. Here I call it lib.wasm, but I think I called it my lib.wasm. Let's just take a look. Yeah. And we open the file and then convert it into a byte array. This is what we pass to WASM module. I'll make a note here. We have to use pythonmonkey.new because WebAssembly.module is a class in JavaScript that expects to be called with the new keyword. This new keyword specifies some things in the object and is required for it to be instantiated. So pm.new, since Python doesn't have its own new keyword, is the way of calling constructors in PythonMonkey from JavaScript. And then here we pass in the parameters to the constructor. In this case, it's just the byte array from the WASM file. And then we call pm.new, so new WebAssembly.instance, with WASM module and import objects. Import object, it basically specifies the environment for the WebAssembly to run in. So we're going to put stuff here like how much memory and what table, and also give it a function to execute when it aborts. This is a pretty standard C environment for WebAssembly I found online. It might not scale well for certain applications, so you might consider changing it if you use this as a base project. So anyways, we call pm.new with the WebAssembly.instance, and we pass in our WASM module here and our import object here, which specifies the environment. And then we get the exports of that into this myclib. And then in this line, we try calling it. So let's try executing this code and see if it works. Awesome, we get 3.0. That's exactly what we expected, because if you pass in 1 and 2, you get 3. But let's expand on this a bit more. Let's add a new function, subtract. This time it's just a minus b instead of a plus b. So if we go to our Python code, I'll just replace this with subtract, and we'll give this a shot after compiling the C code into WebAssembly with the new function. So again, that's emcc lib.c -s wasm equals 1 -s side module equals 1 -o mylib.wasm. Everything compiled fine. Let's try running our Python code that now uses the subtract function from that library. And we get -1 as expected. So I hope this kind of provides maybe a good starting ground for writing your own C library or using a pre-existing C library within Python. You can imagine how instead of having very boring functions like add and subtract, you could use the power of PythonMonkey to have very complicated structures in WebAssembly and using them from Python.
Well, in this video, we wrote a C library, compiled it to WebAssembly using emscripten, and loaded it into Python using the power of PythonMonkey. Although we could have compiled the C code to natively compiled code instead of WebAssembly, WebAssembly means that we have a nice sandbox and secure runtime, and also provides a small binary. Oh, I forgot to mention, it's also extremely portable. And using the power of PythonMonkey made this super easy. The API for calling these functions was as simple as just loading the file and calling the function. But PythonMonkey does a lot more than just executing WebAssembly. You can use it for any arbitrary JavaScript code. And if you're interested in that, check out the links in the description to this video. where there's going to be a lot more examples showing PythonMonkey for WebAssembly as well as just general JavaScript programming. And if you like this video specifically, you might also enjoy the one I made on using PythonMonkey to run Rust compiled to WebAssembly. Anyways, thanks for watching the video and have a great day.